So for the next one, 270 degrees, okay? For that one, right, we want to get that in radians, same idea. You're converting. You convert pi over 180 degrees. You multiply by that. Again, degrees cancel. You get 270 times pi over 180. And you can actually reduce that to 3 pi over 2. You can do that. 2 pi over 3 radians, right? But now we're in radians, okay? So now to convert to degrees, you're going to multiply by 180 degrees over pi. Okay? So that's what you do here. 180 degrees over pi. Okay. So we do that, we get this, and you, oh, sorry, wait. Sorry, wrong button. So what we do when we do that, the pi's cancel, right? Pi does represent a number, and you end up with this product. You know, you get 2 times 180 degrees over 3, which is 2 times 60 degrees, which is 120 degrees. Okay? Good, good. All right. And then pi over 6 radians on the last one. Here, you're going to multiply by this, 180 degrees over pi. And just like before, the pi's canceled, you get 30 degrees. So really, the conversion is what we care about in this class. Good. All right. Are there any questions about this? Okay. Originally, I was going to have people try this, but I did email the notes with the solutions already. So let's just get right into this. So let's convert 45 degrees to radians. So for this one, okay, so for this one, right, we're going to multiply by pi over 180 degrees, right? Doing so, we'll get the degrees will actually cancel, and we'll get 45 pi over 180, which is this. You can reduce that actually because 180 is 45 times 4, so you get pi over 4. And again, you know, I know over here I wrote out radians. I mean, it's not really wrong to do that, but people generally don't do that though. But I didn't write it here. So, okay. 135 degrees, same idea, right? You just multiply. Right? You get 135 pi over 180. And you can reduce that. You end up with 3 pi over 4. Okay. And now radians to degrees, again, you have to basically go the other way in the sense that you multiply now by 180 degrees over pi. By multiplying now, pi's cancel, and you get this, 60 degrees. You have 5 pi over 6, same idea, you multiply, right? The pi's cancel. And you get 5 times 180 degrees over 6, which is 150 degrees. Generally, the pi's are going to cancel. People don't usually have pi degrees. People don't usually write that, as far as I know, at least. I mean, I don't think it's technically wrong to do that, but as far as I know, people don't write pi degrees. 2 pi over 5, okay? That's equal to 2 pi over 5 times 180 degrees over pi. And same story. You know, you end up with 2 times 180 degrees over pi, which is 72 degrees. So, you know, just some more examples. Again, originally I was going to have everyone try this, but, you know, I sent the solutions already by mistake, but that's okay. All right. Are there any questions on that? All right. Okay, so that's really all I wanted to do for angles. I mean, there is more, of course, in the book. They do the definition of what a radian is, for instance. But now I want to move on to right triangle trigonometry. And before we do that, I have to do a little bit of a setup. So we're going to be, we work with here a right triangle. Okay? Let's suppose we're working with a right, suppose we have a right triangle. Okay? Now, again, that's a triangle where one of the angles is 90 degrees. Generally, the way we denote the 90-degree angle, we're going to use a little square like this. That tells you this angle is 90 degrees. And we're going to let theta be one of the other angles. Theta. That's this Greek letter. Now, really, it could be here or it could be up here. It really doesn't matter that much. You do have to be a little bit careful because we're going to label the other side. Note that theta is between 0 degrees and 90 degrees. Okay? Theta is between 0 degrees and 90 degrees. Now, okay, so now that's what we have. So theta, okay, now hyp, HYP, that's the length of the side opposite the 90-degree angle. That is, it's the length of the hypotenuse. And the hypotenuse is the side opposite the 90-degree angle. Okay? Okay, so that's what we have there. All right. OPP, that's the length of the side opposite theta. Adjacent is the length of the side next to theta, like so. Now you could put theta up here if you wanted to. Hyp is still the length of the hypotenuse. The hypotenuse is, again, the side opposite the 90-degree angle. So this is still the same. This is the length of the side next to theta. OPP here, this is the length of the side opposite theta. So if you put theta up here, these two are going to switch. In other words, that's okay. Once we have that, we can define trig functions. Namely, we have this. We have our trig function. Sine of theta is the length of the opposite side divided by the length of the hypotenuse. That's what this is telling you. Cosine is the length of the adjacent divided by the length of the hypotenuse. Tangent is the length of theta. Okay? Excuse me, tangent, what am I saying? Tangent is the length of the opposite side over the length of the adjacent side. So, yeah, someone had a question?
I don't think you sent the notes to the email.
First one I did. Let me see.
Or I didn't get them, definitely.
Let me take a look.